Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination mechanism and the kinetic isotope effect, Ki. Moving on to the next step. Identify the mechanism. Both reactions proceed via E2 by molecular elimination with IChO as the base. In E2, the rate determining step involves simultaneous removal of a beta hydrogen or deuterium by the base, breaking of the CH-D bond and departure of the leaving group, Br. Moving on to the next step. Reaction 1 analysis. In 3-bromopropyl benzene, pH CH2 CH2 CH2Br, the beta carbon to the Br bears regular hydrogen atoms, CH bonds. IChO abstracts a beta H in the rate determining step. No isotope effect applies. And for the final step. Reaction 2 analysis. In pH CD2 CH2Br, the beta carbon, the CD2 group, bears deuterium atoms instead of hydrogen. IChO must abstract a beta D in the rate determining step to form pH CD is equal to CH2. Because the C to D bond has a lower 0-point energy than CH, deuterium is heavier, the activation energy for C to D bond breaking is higher than for CH bond breaking. Primary kinetic isotope effect. The primary Ki, Kh, Kd typically ranges from 2 to 7 at room temperature. Since reaction 1 involves CH bond breaking and reaction 2 involves C to D bond breaking at the beta position, R1 R2 due to the primary kinetic isotope effect. Why other options fail? B. R1 is equal to R2 is wrong because Ki makes CH abstraction faster than C to D abstraction. C. R2 R1 is wrong because C to D bonds are stronger, harder to break. D. R1 is equal to R2 2 is wrong, the ratio goes in the opposite direction and the numerical factor is not supported. Therefore, the correct answer is A. Therefore, the correct answer is option A.